Hello, everyone. Welcome to AI for All YouTube channel. This is Silva Jagannathan, and today we will talk about the hot area within Gen AI that everyone is talking about and absolutely necessary to make Gen AI truly useful for search. That is retrieval augmented generation. And if you are a professional that is seeking to advance your understanding of Gen AI, or you are a technically minded individual curious about the mechanics of how AI works and AI's use cases, and you are someone who strives for technical proficiency in general in your conversations at your workplace or personal life, you are at the right place. Well, before we get started about retrieval augmented generation, also known as RAG, let's understand why RAG. We normally think LLM knows everything because it is trained on a massive amount of data. But when you think of LLM as nothing but a probabilistic next word generator, which it is, you know that it has just learned the patterns of the language. Its knowledge is limited by what it is trained on, and it could be outdated. Just imagine someone that went into coma in 2019 and waking up today to be asked about what is COVID 19, right? They cannot answer that question, or they're going to make up some stuff, which we call hallucinations in Gen AI. So, what does RAG do to it? By using RAG, you supplement LLM to increase its accuracy of response, improve the relevance of its response, reduce its hallucinations, and provide additional capabilities to LLM to act as a chatbot, um, search engine, etc. So, RAG is changing the way we interact with information. They are powering advanced chatbots to improve search engine results and even helping with complex research tasks, making information access more efficient and accurate. A RAG technology follows a four-step process. The first step is to organize the data. That is, organize your documents, convert them into numerical representations so that computers can interpret the text. And second step is where the user provides the query in the natural language to the system. And thirdly, retrieving the data, that is fetching the relevant data from the database where the unstructured data is stored as numerical representation. And finally, generate, where the model uses the data that it fetched from the documents and generates it as a response, meaningful response to the search query with the context. Now, in the upcoming slides, we will look into a little bit more details on what steps go behind this four-step process. Firstly, within organize. What does organize do? In this step, the document's text is read. After reading, chunks of text with overlaps of text are created. That is, you might wonder why I have them capitalized, chunk and overlap capitalized. That's because I have, those two are the most important input levers for a retrieval augmented generation system, and I will explain a little bit more later on those. Then the third step is to convert the text into numerical representations, also known as embeddings, using pre trained language models. The language models that you use here could be a good example is text embedding Gecko model that's available on Vertex AI on Google Cloud, or you could use any other custom models. Um, and finally, you convert the text after you convert the text into numerical representations, you need to store them somewhere so the subsequent steps can refer to this database. So in this case, you will be putting it in somewhere in a vertex database. A good vertex database example would be BigQuery or vertex matching engine. And there are many other databases like this available in open source. The next step is querying step. This is where search query is entered by the user in the UI in natural language. The entered search query is converted into numerical representations, which will be used by the next step to do matching. The next step is retrieve. The numerical representation of the search query is looked up in the vector store of the document for similar text. And once it identifies the similar text in the vector space, similar chunks of text from vector store are identified and then combined and put sent as context to the next step, which is the generate step. And in the generate step, we prompt the LLM, such as Gemini or GPT, to use this context as input and respond only based on that context. We make sure to include statements such as if you don't know the information, or if there is no context, um, then just say I don't know the answer to that. This is to prevent hallucinations by the LLM. And there are many more prompt engineering principles that you can find in the promptingguide.ai website. It's all free for you to access and learn. And the next step, once you instruct the LLM, and when and you pass the context to the API call, and at that point the LLM takes the context, it compares it to the question, and then it answers in the way with the context and the relevance that is needed for the search query. There you go. That's it. You have a retrieval augmented generation system in place. Now let's talk about chunk size and overlap size. As an example, let's take the text that you see within double quotes is the document that you're feeding in to the organize step, which is the step one. As part of that, you let the system know that you want to break the text in 10 word chunks. And so you can see that there are five phrases that came out of that sentence, the sentences that were given, the paragraph that was given as input, and each chunk has a maximum of 10 words. And also notice that there are four words that overlap with the nearby chunks, and that's because we have given the overlap size as 4 words. Now you can tweak these inputs to something else and create different number of chunks, but there are some advantages and disadvantages to it. For example, if you have smaller chunk size, the, there is less context in each phrase, right? Likewise, if you have overlap sizes, smaller overlap size, that also leads to less context because you have smaller phrases, and you have um, less overlap. So the connection between the system is not able to make understand the proper context and respond to the search query. Whereas if the chunk size is, but having said that, having a smaller chunk size means you have faster retrieval. On the other hand, if you have larger chunk size, you get better context, but you also get more noise. The overlap size, when it is large, you get coherent responses, and usually higher overlap size is suitable for large documents which have like long sentences. Um, Now, there is no this is not a science to say this is the chunk size and overlap size that you should use. It's something that you should experiment and decide it for yourself. Um, and finally, what could you do from here on? Things that you can do. You can. So I'm intending to do a separate presentation on um, writing a RAG program using Python. But for the moment, you can leverage the document Q&A with RAG code sample that's available on GitHub. It's based on Google Cloud. And secondly, there is RAG architecture that you can read about as to how you will implement a RAG system on Google Cloud. And finally, there is a nice course on deeplearning.ai about building and evaluating advanced RAG applications. Um, Read them, have fun. See you in the next video. Thank you.